and we'll use the results of these analysis to determine the pretension in the cables. So load analysis, results, load combination. Here we'll create the first load combination 1 with all the load cases. Tension 2. Okay. Now we'll use the function special for the cables, so which is called the unknown load factor. Add new, call it unknown. So it is a method using optimization technique. Use the square method. The unknown will be both the sign. Okay. Select all and uncheck the self-width and the additional load. So you see here the factors for the tension 1, 2, 3 until 20 are the unknowns. Now we'll enter the constraints. So the constraint will actually define the constraints for the optimization. And using these constraints, the software will automatically calculate the factor for the prestress of the cable. So we'll begin by the node 23 reaction. It will be displacement, okay, dz, inequality, check and enter the upper and lower boundary. Okay, and do the same for all the nodes until the node 45, and excluding the node 35 because it was deleted when we merged the node at the beginning. Again, as it is a bit inconvenient to do all that, I will use the MCT shell. Okay. Click on OK. Go in the tool, MCT shell. This time the command is uncons, insert the data, and we have to copy these until 45 and suppress the node 35. Click on run, so click on close. Now come back into the result tab, unknown load factor, modify, and you see all the nodes have been added here automatically. Now check all these nodes and click on get unknown factor. Check the influence matrix And here in the constraint part you have all the coefficients which have been determined by the optimization technique. So actually there's a method to tune the cable force using this screen. So you can define all the tension. Oh yes, first you have to go back in this window, make a new load combination, so it will be LCB2. Okay, then cable force tuning. Here you have all the tension entered, and in this window here we'll create a new result. So if you want to tune in function of the deck moment, you have to create here. So here I have no group for the deck, so I will close that, come back to model view and create a new structural group. So it will be the deck. Now select the element from the deck and drag and drop this to add this element to this group. Now come back to cable force tuning, deck moment, use beam force FZ element DZ, add it here, and you see you have the deformation of so this is the moment of the deck. You can define a range, so between, let's say, 1000 and -1000. Okay, and you can tune the cables in order for the moment to stay inside this area. So if you change here the area is a bit big, but let's say you want 500 and -500, like that. You see at this range the moment is a bit too big, so you can tune the cables, you can change the value and it will change in real time. So you have to choose the right values and to try with different values to see what is working. But it's not the purpose of this tutorial today, so I will just close this. We will have more advanced tutorial on this subject later, so don't forget to subscribe to my YouTube channel to follow the next tutorial on this subject. Now I created a new load which is using these calculated pretension loads. So you have to calculate again the results. So come back in this mode, analysis, perform analysis, and if you go in the deformation window, deform shape, you can select the LCB2 deformation, activate uniform, legend, values, apply. Okay. Let's review the DZ deformation. So you have something like that. Hide the nodes and the elements. Hide the value of deformation. So this is the deformed shape on the bridge. If you want, you can decrease the deformation scale factor. You can see other results like the displacement contour. Okay, so here you have the value of the displacement. Next step will be to show you how to perform the construction stage analysis for this cable stayed bridge. So this tutorial will be for next week, so don't forget to subscribe to the channel in order to follow next week's tutorial about the construction stage analysis of this cable stayed bridge. Thank you for watching.